Hi, this is Professor Thone from Pasadena City College, and in this video I'm going to be going over instructions on how to assemble your own power supply for ELTN 130. Make sure you check out the PowerPoint that is associated with this assembly process. Here are the tools that we're going to be using for soldering. We have a Weller soldering iron, which is going to be a little bit different than the soldering iron that you're going to be using. In this case, when I turn it on, I set the temperature to about 625 degrees. On the soldering iron itself, there's a sponge on the soldering station. There's a sponge. We usually want to get that a little bit wet. I'll pour a little bit of water here. Notice that I don't flood it. I don't want the soldering iron tip to get too cooled off when I wipe it off. If you take a look at the tip of the iron itself, you'll notice it kind of looks a little bit discolored, kind of cruddy. Once it gets up to temperature, if I wipe that tip of that iron off, it should look very shiny. That indicates that it's cleaned off all of the oxides. That's important that you do that frequently because you'll notice even in a few seconds here, it's already started to kind of look dull again. So you want to wipe that tip clean every time before you make a solder connection. I typically will put all my parts in a bin. This could just be a little Tupperware container or something small. But that keeps your parts organized and keeps them from falling out or getting lost. Resistors in particular are very easy to lose. I use helping hands. That kind of keeps everything stable when you're doing soldering. And then I'm using solder here. A couple important things about it. If you look at the label, it says SN63PB37. That means that it's a 63% tin, 37% lead blend, which is very good for soldering. And then the diameter is fairly small, 0.5 millimeters or 0.020 inches. So that's what you want to do to kind of get ready before you actually start building your project. The first component we're going to be soldering on is R1, the 360 ohm resistor. By using the color code, I can identify this part as being orange, green, and brown. Usually I'd use a component former tool or a lead forming tool to bend the leads. In this case, I'm going to simply bend them at kind of an easy angle here. And then that should fit fairly easily into the board. Now if it's bent a little bit further, that's okay. But once the part is placed in there, it doesn't matter which direction we have the resistor. There's no polarity involved with it. Okay? But what is important is that the component is very flat to the board. We do not want what they call skyscrapers, where one of the parts or the ends is sticking up higher than the other, like that. It doesn't really cause a problem, but it just doesn't look very good. It doesn't look very professional. Once I've placed the component on the top of the board, I need to bend the leads out a little bit at a very slight angle just to make sure that it doesn't fall out when we're actually doing the soldering. I'll then put it back in the helping hands so that now I'm ready to solder the connections. Before soldering the connection, if I pull the tip of the iron out, you'll notice that it looks very dull. So what I need to do first is clean it off, wipe it on the sponge, and it looks a lot shinier, but then I'm going to apply a little bit of solder. That basically gives more surface area for the solder to make the connection with. When I solder, again, I put a little bit of solder on the tip already. Put just a little bit more. Okay. The main thing I want to do is heat the connection, apply solder, and remove the tip. This is usually very fast, less than 2 seconds for sure, maybe around a second. I'm going to do the same thing with the other connection. Now between those two steps, I wiped the tip of the iron to clean it off. Apply a little bit of solder to the tip of the iron, heat the connection, apply the solder, and let it flow over the connection. Now I'm going to show you a couple of mistakes that people make. Sometimes people apply solder to the tip and then try to wipe the solder on. Solder is not a glue, and when that smoke that you see, the flux burns away, it will not clean off the oxides or any of the dirt that's near the connection. Secondly, you do not want to hold the iron for a long period of time. Sometimes people will try to hold the tip and then dab the solder on. You want to do it in one clean move. So I'll show you here how we do it. Heat the connection, make sure it gets hot, apply a little bit of solder, remove the solder, then remove the tip of the iron. Once that's done, you should have a very good connection. The connection should almost look kind of like a triangle, not a ball for sure, but something that looks like it's sloping up from the base of the circuit board to the top of the connection point. Once I've soldered those, I'm going to clip the leads. You want to make sure the leads are not hot. I'm going to use my wire cutter here, hold the wire, and clip the lead fairly close to the board. Next, I'm going to solder the other two resistors, R2 in the top left corner and R3 towards the bottom. Notice something very important is that R3, even though it's marked for 10K on the circuit board, is actually a 1K resistor. So we're going to use a brown, black, red resistor, a 1K resistor for that device. You'll notice that I don't insert all of the components in at first and then solder. It gets difficult if you have a bunch of wires. Also, it's a good practice to kind of check your work as you go, as you're progressing, and make sure that everything is correct so you don't make mistakes. I'll demonstrate this one more time. I clean off the tip of the iron, apply a little bit of solder to the tip of the iron, heat the connection, apply the solder, and remove the solder. Next, I'll solder the diodes. What's important is that if you look at the symbol for the diode, or the actual silkscreen for the diode, you'll notice that there's kind of a white band there, a gray band. That is the same as the gray band that you actually see on the diode. So make sure that when you solder them on, you're lining them up properly like that. When finished, you should have the 6 diodes soldered as shown. Next, solder C3 and C7, the 2 capacitors. They might look a little bit different on my board than yours. By the way, these capacitors are what are called non-polarized. There is no plus or negative terminal, so it doesn't really matter which way you solder them in, just like resistors. The next components we'll be soldering are the polarized or electrolytic capacitors. You'll notice that one lead is longer than the other. That indicates the positive lead. Also, there's a line, like a minus sign, on one side of the capacitor. That's the negative side. So if we take a look at our board, you'll see where the positive mark is for the capacitor. So make sure that you put the longer lead in that hole. The next component we're soldering is the LED, called LED1. You'll notice too that it has a longer and a shorter lead. The longer lead is the positive, the shorter is the negative. Also, there's a flat on the side of the LED, and that indicates the negative terminal too. That also matches, if you take a look at the silkscreen, a flat on the board itself. Next are terminal blocks. Terminal blocks are devices that allow us to use wires to connect to the circuit board. What's important about the placement in this case is that the holes on the ends always go to the edge of the board. So when I'm placing that on the circuit board, like that, you want to make sure that the holes are facing out. That's the way the wires will come into the board. Another recommendation I would make, if you find that your components aren't very straight or not getting soldered flat to the board, one method you could do is solder just one lead to start with, then flip the board over and see if the component is lined up well and if it's flat to the board. In this case, my LED is kind of off the board a little bit. You'll notice it's standing up, which isn't good because it could eventually bend or get broken off. So what I'll do is I'll flip the board over in this case, pushing with my finger from the other side, reheating the connection, and then pushing the LED up. Now the LED is nice and flat to the board. If it's a little crooked, I can straighten it out. So that's a good method, just doing once. Now that I've got that one soldered connection that's good, I can solder the other one. Soldering the terminal blocks can be a little tricky because they tend to fall out. One method I could use is to put a little bit of tape on the terminal block and hold it in place before it's soldered. In this case, I place some tape on the top of the board, and that will hold the terminal block in place when I'm soldering it. You have to make sure, however, that the tape doesn't actually touch the soldering iron or it'll melt. Here's a close-up shot of the terminal blocks and how they're soldered. you'll notice that there's just kind of a triangle, kind of a shape, or a volcano, sometimes they call it, coming up towards the tip of the actual connection point. Make sure again that the open ends are facing out from the end of the board. The next two components that we'll be soldering are the voltage regulators. They're IC1 and IC2 on the board. If you look carefully, you can see the number LM317 for one of them, which is IC1, and L7805 is the second one. Before soldering IC1 on, I'm going to slide what's called a heat sink in position over the hole, and I'm also going to bend the leads of the voltage regulator. I'm kind of bending them at a kind of a 45-degree angle. What this does is it allows me to place the component in the holes and make sure that it's spaced properly so that it's not pushed down too far on the circuit board. In a second, I'll show you why this is important. In this case, I soldered one pin on the bottom of the board. Then I used a screw and a small nut to attach the voltage regulator and the heatsink to the board. So if we look on the back side, it looks something like this. You can tighten this with a small pliers or a small screwdriver. You don't have to over tighten it. The reason I soldered one lead is I wanted to make sure I didn't solder them all and then have to bend the device in order for it to be flat against the board. The next component is R4, which is a potentiometer. It looks like this. If you look very carefully, you see a small cat hair on it. That will not affect the operation. On the side of the potentiometer are two tabs that basically snap into place and provide mechanical support for the potentiometer. When you press it in, you'll hear kind of a click as it goes into place. So on the other side of the board, you'll notice those two tabs, they don't really hold, there's nothing electrically connected to them, but they'll still be soldered, and that will provide some mechanical support for the device as it's rotated. Because the holding tabs are a lot larger than regular leads, we need to hold the soldering iron for a little bit longer to make sure that it's connected. I'll apply a little bit of solder to the tip, hold the tip to the point, let it heat up, and then apply a fair amount of solder. We don't need to put too much, but just enough to basically cover the pads and hold it in place. Once that's done, I will solder the rest of the leads. Almost done. Capacitors C1 and C2 are very tall. They're long devices. If we solder them to the top of the board, we would not be able to turn the knob. It wouldn't fit in the enclosure. So this is something a little bit different. We're going to solder them to the bottom of the board. Again, the long lead is the positive lead, the short lead is the negative lead, but we're going to insert these from the bottom and solder them. So this is what the capacitors look like on the bottom of the board. The last component that we're going to solder to the board is a small LED display that will display the voltage. In order to solder it on, we're going to be soldering to pads 1 and 2. It's a little hard to see where these are because it's hard to see where it says pad 1, but these two pads. In order to solder that on, if you look at the PowerPoint, it gives some instructions on how to twist the leads together. So I cut the leads, in this case, and twist them together as close as I can. Once that's done, I can slide this very carefully into those two holes like that. Now in this case, it's difficult to solder it from the other side to keep it from falling out. So I'm going to do something a little bit different. I'm going to actually solder it from the top of the board. Now you'll notice that this component doesn't have any really way of mounting except there's some small screw holes on the side. Whoops, let's get that on there. There we go. So now those are soldered on there. You have to also make sure that those two wires don't touch. Now unfortunately we don't have screws to hold those in place. But if you have some hot glue or some epoxy, it's fairly easy to glue that onto the board. Once you're done with that, you're done with soldering all the components on the board. Next step before we do the major assembly or putting it in the box is we're going to actually test it.